We have two presenters today. Ben Rajewski is a P.Eng, LC, Well AP, and the electrical team lead at Williams Engineering. And we've also got Adam Behiels, P.Eng, LC, and project manager at Mulvey and Banani. And with that, I'll let them take it away.
All right. Yes, welcome. Thanks for attending today. We're going to be presenting a seminar on lighting upgrades for commercial and institutional spaces with some updates for current technology. This presentation will primarily give a visual overview of IES standard LEM 313. Since this presentation was originally authored in 2013, that time LEDs were just starting to see some adoption for interiors. This said, a large proportion of the standard is related to fluorescent technology, which is now kind of on its way out. We're not upgrading to fluorescents now, we're replacing fluorescents. So we've updated a few of the sections in this presentation to account for the more LED-centric environment we're now working in. Turn over to Ben.
So I guess, why would you want to upgrade your lighting? Essentially, it comes down to money. Both you're going to save money by spending less money on energy by going to high efficiency LED fixtures, and hopefully by also increasing the quality of your lighting, you're going to be increasing your employee productivity, which will also save you money by making you more money because people will be working faster, harder, better for you. So you want to upgrade lighting to make your savings better overall.
All right, so what's lighting upgrade? We generally talk either retrofit or redesign. Now, in retrofit, it's usually a modification of the lighting system or luminaires to get better performance, lower the energy. And a redesign, we're looking more at changing the layout most times. Change the layout, introducing new luminaires, possibly new measures, new areas of light. In practice, you're usually getting a combination of these. Your retrofit measures are good on a per fixture energy use basis. Sometimes the programming of the space may mean you want to have a different layout, or a simple straight retrofit just is not going to work. So yeah, you see a combination of the two. Redesign sometimes let you eliminate fixtures altogether, which is a big energy savings. Go to the next slide.
Yeah, so you can get energy savings through a few ways. If you've got older technology, T12s, HID, incandescent lamps, these are high energy users, and going to something even like a fluorescent or now more likely LEDs is going to save you energy just based on straight wattage. If the space is designed with too high of light levels to begin with, you're going to save money by just dropping it down to a reasonable level for the light level that's actually needed in the space. If you've got damaged lenses that are covered in dirt, dust, bugs, that sort of thing, just cleaning the lenses is going to give you a better light output, so you could get some efficiency out of there. If your fixtures are dying because the ballasts aren't working, they're flickering, that sort of thing, you can save energy there. And lastly, if you don't have a control system, your building is operating with 24/7 lighting, like you drive downtown, you see a high-rise building at 3 in the morning, all the lights are on. In an office, nobody's there. You need a control system. You can save money just by turning off the lights when nobody's in the building. So save money by using less energy. The picture on the right shows you've got these old T12 fixtures with inefficient ballasts. You've got a lot of like 100-foot candles or 1,000 lux in a space that probably needs 300 lux. So you could reduce the number of fixtures. You could make the fixtures more efficient. You could add lenses that are not cracked and broken, and you could deal with some of these other failing issues to make the space more efficient, better lit, brighter, while still saving a lot of energy.
So when to redesign? Generally speaking, existing lighting layouts will illuminate space adequately for lighting upgrade. However, current retrofit options may not always be the best solution. You really want to take a look at the existing lighting. If it's serving the user for what they need to do. Are the lighting levels sufficient for the required tasks? If there's a really poor uniformity in some spaces where they've moved in furniture or moved in desks, someone's not getting light, you definitely need more fixtures there. On the flip side, you may have older offices designed for higher lumen depreciation, since maybe those offices were built at a time where they had smoking in the offices, where they're expecting a lot of depreciation in output. And now simply going straight replace with a new T8 new lens or something, a new LED tube, you might see almost too much light. So you may need to delete fixtures in that case. Other times, existing luminaires are in poor condition. You can't put new stuff in them because they're in such bad shape. Or simply putting an LED tube into them would produce glare. And if you're going to change the light distribution too much to a point that you're producing more glare or bad uniformity, then maybe you have to look at a redesign. Yeah, so we go to the next slide.
So what is the lighting upgrade process? First, there's going to be an initial assessment. Do you have inefficient fixtures? Do you have T12 still all over your building? Do you have HID fixtures that are failing? You're going to check that. Then you're going to think about whether, does it make sense, like Adam said, to redesign the space, or does it make sense just to retrofit the existing fixtures with new bulbs? And how much, and partially that'll depend on how much money you've got funding wise. Often a lot of sophisticated owners will do this sort of step themselves, and then they'll bring engineers in after for the full assessment. Once they've decided, hey, we want to replace all our lights with LEDs, then the engineer is going to come in, survey the building, see what they've got, light levels, type of fixtures, and what can be done with what they've got to upgrade. Then we'll design it, do a cost analysis. We should be able to give an ROI on what they'll get back with the lighting upgrade and how long it'll take to get the savings. And then we'll do our design so that a contractor can install it, build it, commission it, and have it done. So there's kind of the 4 steps. I would say as lighting designers, we're really involved in the second step, and then obviously we see it through construction. And possibly we may be able to help some building owners on the first step as well if they're less sophisticated and need some help.
So here's kind of an overview of section 2 of the standard. Here they cover components of all lighting upgrades, no matter the specifics. We'll touch on all of these in further detail in subsequent slides, but this will include the assessment procedures, what quality illumination really means, briefly at least. Service maintenance issues, you want to basically be improving these. Economic issues, how we're saving the owner money with the upgrade. What we should watch for in calibration and commissioning. Codes and standards to be conscious of. Don't forget about disposal issues, as well as what equivalent alternatives there are out there. Over to you, Ben.
Yeah, so what is in a lighting assessment toolkit? I'm actually heading to do a first pass at a lighting assessment this afternoon, right after this project. So in my toolkit, I just printed out the drawings. I'm gonna bring my phone with the camera. You got your light meter to check kind of the levels that they're getting right now. And then you may want, depending on the site, you might need your PPE. You're obviously gonna want to take some notes. You may need more advanced things like a ballast checker or a mirror if you're trying to kind of see up into things to get some information off of the existing fixtures. So just kind of the basic things, but generally having drawings is really helpful to begin with. So you can as built and see what's there and what's needs to be changed. Yeah, so then you're gonna look at the site, kind of figure out what the owner's trying to achieve with regards to payback. Is there any incentives right now for replacement to LED or energy efficiency upgrades? Does it look like the existing fixtures have PCB ballasts or things like that that we're going to have to dispose in a special way? And then we're going to survey all the rooms, see what the fixtures are there now and what what we could possibly change with them, do some lighting calcs to do the levels to what we think they need to be now to meet IES standards, and then develop your luminaire schedule and figure out the next steps.
So next, we move on to economic issues. This section of the standard describes a simple procedure that will lead to realistic savings projections. However, a full life cycle cost benefit analysis would be more accurate. For something more along that line, you want to look at RP 3114 as a very thorough explanation of economic analysis for lighting upgrades. Generally, in practice, simple payback will often suffice. I find that like so far, I've not come across clients so sophisticated they want really advanced life cycle costing or rate of return financing calculations. Usually, an energy savings idea, how much time that those, the upgrade will pay off in, is generally good enough. But if you have a client who's demanding more than that, where you want to kind of sell it better, there are different resources there. Let's move on to the next slide, Ben. So simple payback is just that. You add up your annual proposed savings based on your proposed luminaires you're putting in, and divide your estimated cost by these savings. LEM3 includes discussion of lowering the lighting power density for energy codes and a reduction in annual demand. Now, it'll depend on your utility. Sometimes a reduction in annual demand can mean a reduction in charges. And for lighting power density, it may come into effect if your installation becomes something you need to get a permit for, in which case NECB can kick in, where you need to look at your lighting power densities in each room and each floor and bring them down. So yeah, a few things you need to check there, but all in all, start with simple payback and see where that gets you. That can be a simple one. You can even set it up as you're doing your takeoffs, have a running kind of payback to have an idea of where you're at. Okay. Head to the next slide. In general, simple payback is based on energy savings, is easiest to grasp for client. When you do really want to sell value of a project, it can be beneficial to include other life cycle costs. In general, older tech is higher cost to maintain. One caveat being new LED luminaire replacement at end of life. This is something a bit contentious. That's not something vendors have really answered, is what's going to happen to my fixture in 20 years when it's got to be replaced. Yes, we saved a lot of energy in that time, but now my fixture replacement is, $300 per fixture now for a large portion by installed base. What now? Is that part of our life cycle cost or not? So that question will be answered in time, but in the meantime, it's good to make the owners you're talking to aware of that risk. But that said, better manufacturers are coming up with modules that can be changed out. The array can be changed out. Drivers have been replaceable in a lot of luminaires for a while now. So there is a way to manage that, but it's something to keep in mind. Other things to consider, just reduce maintenance expenses. That's a big one to highlight. Most LEDs last longer than any existing fluorescent installed base. How you're going to manage a group relamping plan. If you're going with LED tubes, maybe if they're a hard to reach location, you may want to do a group relamping because it may be really costly to build scaffolding, what have you. Plan for disposal costs. If in any case, when you're changing out lamps, there's going to be a cost to getting rid of the old stuff. Third-party financing, not something we always get involved in as lighting designers, but it can come up. Like I said about demand charges, this is something more you have to check with utility. If it is an issue in that site, maybe something to look at. Reducing cooling loads, it's definitely a benefit. It can be hard to quantify that. It's not something that usually gets into unless you're doing a new build, looking at energy modeling, then it might be incorporated. And as far as looking at labor rates, yeah, it's good to have a peg a labor rate, talk to your client about what you're deciding on. Guess moving on to the next slide, Ben.
Yeah. So what is good lighting? I often think about, like, in an office, good lighting is lighting that you don't even notice is there. You just want to walk into your office, be able to do your work, and not worry about whether the lighting is bright enough or is it glary. Are you having trouble reading what you're doing? And that's not just for an office, that's for a lot of places where lighting is not the focal feature of what's going on in the space. It's just there to help people do what they want to do. So you want uniform light distribution, you want lighting that's comfortable, glare free. In a lot of places, color rendering is important as well, like especially in grocery stores, things like that, where you're, or any retail really, where you're trying to show off a product. Task lighting is important. If you're at a bench and you're soldering or you're doing something like that, you want to be able to see what you're doing. And flickering, of course, is a problem, especially you don't want to cause seizures or even any of those sorts of issues. So good lighting to me is lighting that's uniform. And you're really not worried about it. It's doing what it's supposed to do so people can get their tasks done. And important to note is more light doesn't mean better light. So I've often had the case where people complain after they get a lighting upgrade that it's too bright in the space now, partially because they've been sitting in an extremely dark area and they're not used to it, but people don't necessarily need more light depending on the task. So more light doesn't mean better light. If you've got uniform light, that's probably better than super bright glary light. So that's something to keep in mind. So when we're looking at lighting quality for redesign, we want to look at, was the original concept for the lighting, did it make sense? Because often if it makes sense, we can keep a lot of the fundamentals and just do something like a fixture swap or reduce the number of fixtures but keep the intent the same. Can we reduce the number of fixtures? Like I've seen a lot of large open offices that had fixtures back to back to back in long lines with 2 to 4 lamps. Like when we replace with LEDs, nobody needs that many fixtures that close together. So you can reduce the number of fixtures and still achieve the same light level, saving a lot of energy and like a lot of maintenance time. And then the other thing when we're looking at redesign is how important is controllability to the client. Now with LEDs, every fixture can be dimmable pretty much. You can add dimming, you can add that controllability for the scene selection with dimming for meeting rooms, conference rooms, all those sorts of things that fluorescents had a really hard time doing. So if you want extra controllability, if that would really help your client, then a redesign with new controls is probably a great option.
All right, moving on to glare considerations. So glare occurs when bright light sources interfere with the viewing of less bright objects. The contrast may be uncomfortable or even disabling to one's ability to see. Different types of glare. Is direct glare caused by bright source looked in front of viewers. Reflected glare caused by bright reflections in surfaces such as glossy paper or computer screens. I mean, really, with the advent of flat panels, especially if you get a matte finish on them, it's really not really much an issue anymore. And there's overhead glare caused by light luminaires located directly overhead. At certain angles can be kind of veiling. So to prevent this, moving on to the next slide here, few tools you can use. Shield the lamp from view with baffles, louvers, lenses, or diffusing overlays. Reduce the brightness by using lamps with lower luminance. Potentially more luminaires, spread it out more so you're not getting direct points. In office and other low ceilings, applications you should definitely take care when you're putting in new LEDs that they're properly lensed or they're not in direct view where it causes glare. Often, you know, if more indirect it is, the better. Also, we can look at decreasing lamps, maybe relocating sockets within a light luminaire, but still taking care to shield the lamp. And if you've got a larger project where you've got an architect involved, maybe a furniture planner, you can look at using lighter colored matte finishes just to provide more uniformity and spread of the light around the room. move on to color temperature. Now, LED sources can come in a range of 2200 to just about 8000, with most ranging between 2700 to 5000. With the increasing focus on circadian lighting and its potential effect on health, this is becoming a pretty deep topic, which we're not going to go into cover in this presentation. There's been plenty of seminars on that and conferences on this lighting and health topic in the last year or two here. But in any case, talk to your client about the existing color temperature of light and what they'd like to see. General public understanding of color temperature is still a bit shaky. I mean, when CFLs came out, you really saw that people didn't understand what a cool and warm really meant. When in doubt, speak in that language of warmer and cooler. Try to avoid throwing out numbers and acronyms at the client right away. See what their understanding is. Once you get there, what their color temperature is, and where it may look better or where it's going to be with LEDs. What changes they'll see. Once they kind of got that grounding, you can start to move into more advanced things such as circadian lighting or what risk you might run with a different binning of luminaires, where you might have 2700 from one product run looks different from 2700 from another product run. So it's good to discuss the client with these things and don't just put a number on a specification and assume that, yeah, they wanted 4000 in their office or what have you. Moving on to Ben.
All right. So color rendering index. Color rendering is a big thing where we want to make sure that what we're lighting up looks how the way that we naturally expect it to look. So we get the CRI number. So as you can see in the picture, the higher the CRI, the more natural the color will look in an object. Unfortunately, a CRI number doesn't actually indicate exactly what each color will look like. It just kind of gives a general overview of the colors. So the CRI 70 pictures there can both be CRI 70, but you can see that the blue crayon doesn't look as good in the one picture as the other. There's a few, with LEDs now, we're trying to get to that higher CRI 80 or 90 generally to begin with. And then we may want to look at specific, if we're lighting things with red colors of a higher like R9 or red value of the LEDs. There's a new standard out called TM30 that goes into a much greater detail on color rendering. And that's a whole nother IES presentation that we'll probably do at some point. But needless to say, color rendering is important. And if it's important to your client, generally make sure to start with that you're getting at least, you can often get easily CRI 90 with most LED fixtures now, so that would be a good place to start.
All right, so on to code standards. Of course, when you're performing a lighting upgrade, you're doing construction work. You always need to know what applicable codes and standards are in place. Now, energy codes and building codes generally come into play when the scope of work results in a need for a permit. In which cases NECB for LPD and control requirements come in. Building codes, emergency lighting and exit signs are a big one there. There are other points in there that apply. Electrical code, when you're doing any kind of electrical work, definitely always applies. One I'll just point out here that does come into play when you're doing retrofits is equipment marking. And I've got a reference to a stand data here. Effectively, when you're altering a luminaire, whether it's being taken down for modification or modified on site, most times you'll need to have new equipment marking to identify whether lamps have changed, valves or drivers changed out, wiring's changed. So keep that in mind. That's an extra step you need to have. Usually it's describing what the retrofit is to the certification body. They make up a new sticker, contractor puts that sticker on as they go through the retrofit. Just a couple standards to note, C22.2, number 25016. It's more of a manufacturer standard for retrofit kits. And just as far as, I guess, a quality standard, DLC, not every vendor subscribes to it. Doesn't mean they're bad quality, they don't, but it's can be helpful if a client throws a luminaire at you that a salesman told them about and you haven't heard it before. Maybe look at their DLC listing and see where that sits. And just keep in mind, there's a lot of kind of gray label listings in there that will be rebranded by a lot of vendors, and that can be somewhat confusing at times. So you'll have to follow up with the vendor to get their kind of, I guess, gray label unit number to check it there. And yeah, any additional information, there's also an IES standard on codes and standards itself. It's SEM 212. Keep in mind that may be very United States centric. So it's best to consult your AHJ. This is not an exhaustive list here, and see what any further codes may be applicable. Like just yesterday, I found out that I guess in Calgary, the minimum, at least for City of Edmonton locations, the minimum parking lot lighting target is about 50 lux, which is 5 times what IES recommends. So there's some interesting things like that you can find out in local bylaws. So definitely do a code study if you haven't in a while. It's good to take a look. I'll turn it over to Ben.
Yeah, so commissioning and luminaires. First things first is it working? Is the fixture on? Is it operating like you expect? Not only just being on, but is it giving you the light levels that you expected to get out of it, or is something causing it to maybe be dimmed or not operating as you expect? Does it look like it was installed correctly? Is it clean? Is it flush to the ceiling? Is it in the location that you specified? And is it aimed at the target that you want, if aiming is a possibility? And then also, if you have to test if it has a battery pack built in, then the emergency lighting test you would want to do on that as well to see if that's charging the fixture and if it can go on battery power and work off battery. So generally, does it look like it was done correctly and operating as you expected per your design? When you're looking at commissioning lighting controls, again, you want to test all the devices. Often with occupancy sensors, it's a lot of adjustments to make sure that they're installed in the right location, seeing what you want to see so that they go on and off at the right time. You don't want people sitting in their office with a sensor and the lights turning off on them when they're sitting at their desk typing. So the settings are often quite important and need to be calibrated quite a bit. Same with daylighting controls. The daylight sensors are pretty finicky, so getting that right so it dims at the right time and isn't annoying to the people in the room is important. So testing that thoroughly is important. And then with the controls, you want your scene set up, you want your time clock set up, you want your dimming settings set up, and all of the usual passwords, overrides, that sort of thing that the lighting supplier tech should be able to give you when you get your system installed. So essentially just make sure that it's working as you wanted it to work.
Okay, service and maintenance. So whenever you're putting in new lights, you want to think about how they're being maintained long-term. You want to make it as easy on the facilities guy as you can and keep operating costs low. So wherever you can, minimize lamp types. Don't have 15 different beam spreads and sizes where you don't need to have them. Keep your color temperatures at a minimum that you can. Reduce lamp quantities. Yeah, you can reduce lamps in fixtures. Keep just general number down. Extended life lamps. This is more a thing with fluorescent lamps. Generally with LEDs, they're going to be fairly all above 50,000 hours. There are extended ones, better quality ones for sure, that can be taken into consideration. So ballast type lamp life, less concerned with LEDs. It's still something you want to be aware of when you're putting in ballast compatible lamps for LEDs. Ballast maintenance and warranty issues. That said, if we're going with ballast compatible lamps, we're not getting rid of ballast anytime soon. So knowing what comes into play with certain ballasts as far as their maintenance cycle, where warranty comes in, and really educating the user who's replacing it. Know that if you need 3400K in that room, make sure the guy puts in 3400K when those lamps go out. keep in mind how much luminaire depreciation may build up over time. Maybe look at different lensing if it makes it easier. Yeah, in areas where you have hard to reach luminaires, sometimes it can make sense to have a group relamping, have that planned out. And lamp holders, more in over time, for putting new lamps into an existing fixture, it's possible lamp holders may be a bit worn out by the time you're getting into it. You may want to look at just replacing lamp holders to give it a longer life cycle. And when you're redesigning, think about any new measures you put in. How are they going to be maintained? Where's the driver going to go if you're putting a big chandelier over stairs? Maybe think about having remote drivers. You know that those have a certain life. The array may last longer, usually in the range of 100,000 hours or so. But your driver probably isn't going to get too far beyond 50,000 hours. And look at the operating hours, see what that means. And if it makes more sense to do remote BIOS, do so. Yeah, I guess moving on to the next slide here. So good to know that given the existing stock of fluorescent tech in existing offices and institutions, we're going to come across fluorescent technology that needs to be disposed. So almost all fluorescent contain mercury, except those marked eco, but do check this. That may mean different things depending on the manufacturer. And old ballasts, kind of older than 79, contain PCBs as a cooling medium. So this must be disposed of according to regulations. They have EPA listed here. I believe Government of Canada has their own regulations very similar to those. Moving on to next slide, Ben.
Yeah, so I guess our old friend, the T8 lamp, often, I guess at the beginning of my career, we were doing a lot of replacements of T12s with T8s, and it made sense. You have lower wattage than T12s. You can get extended life options up to 60,000 hours, which is in some cases comparable to LEDs. And you have a lamp that has like output that's circular. So you can use the existing reflectors on T12 fixtures and other fixtures to get light where you want it. And generally the lamps are cheap and affordable. So this is something that we're not really doing much anymore, but fluorescents are still quite popular out there. A lot of people have a lot of existing situations where they've got T8 installs that were more recently done. So in that case, they're probably not looking to replace to LED right away. So that's something to keep in mind. T8s are still a relatively good technology, but they're getting surpassed more and more by LEDs. When we're looking at T8s, we got to worry about the ballasts. And when we're doing lamp replacements with LEDs, we still have to worry about the ballast. So ballasts can become an important part of that. There's the different types, the instant start, program start. When you were doing fixtures with many lamps in them, you needed multi-lamp ballasts and possibly more than one ballast in a fixture, depending on how many lamps you did. Dimming with fluorescence is extremely hard and expensive and not great for the lamps. So that's something that LEDs have now greatly surpassed and made much easier. But you're still going to have to worry about ballasts if you're doing lamp replacements with LEDs. So that's something to keep in mind. And then T5s are kind of in a similar situation where LEDs are now just more recently replacing T5s lamps, but they're still quite frequent. We were often replacing high bay HID fixtures with T5HO fixtures. So that's something to keep in mind, that a lot of places have had T5HO upgrades recently or semi-recently, and a lot of those fixtures are still in play. So we'll talk about now what we're all kind of been thinking about the whole time is LEDs. So LEDs are solid state fixtures with no moving parts. They have high lumens per watt output. Generally, their lifespan is quite a bit higher than a lot of previous fixtures. And the one thing to note is they're very directional. So the light's going straight out of the fixture. It's not wrapping all the way around in a non-directional manner. They're not as great in warm environments. They prefer the cold because of the way that their heat output works, and they're instant on. So there's a lot of resources, not just LM313 about LEDs now because they've become so prevalent and popular. When we're looking at performance metrics, we want to look at your total lumen output as well as the lumens per watt. So you may be in a situation where you need more efficient LEDs if you're trying to get a certain lighting power density for your design. You want to look at the lifetime and lumen maintenance of the fixture, color temperature, color rendering, and the cost. The fixture, when you're comparing the fixtures, you're going to compare all of the things I just talked about. And then especially in Edmonton, we want to worry about if we're installing them outside, if they're rated to -40. A lot of them are not right now. You can get some that are though, so that's important to keep in mind. The current LED applications are pretty much everywhere, so that's good. But like we said, be careful with hot environments, high ceilings, which probably will lead to hot environments. If you're dealing with an omnidirectional fixture, LEDs aren't going to work the same way, so keep that in mind. And the maintainability over time is a big one because a lot of, especially the earlier LEDs, didn't have replacement parts or weren't really replaceable. So having replaceable drivers, lenses, that sort of thing over time is something that owners will want to care about. So make sure that the fixtures that you're specifying have these things and can replace the drivers separately from the rest of the fixtures, so you're not just trashing a whole fixture when it does come time to replace LED. When we're looking at lamp efficiency and efficacy, since 2008, when LEDs really started getting going, the efficacy has grown substantially. So now we're nearing that 180 lumens per watt, and maybe it's even been surpassed since this chart was done. So we're quite efficient. It's still getting better. It'll probably level off eventually though, but it's great to see.
All right, so we'll take a look at some LED lamps and retrofit options here. First, with T8 socket compatible LED tubes. Due to a large installed base of T8 fixtures, this is probably the most common retrofit you'll see these days. I guess government energy saving kickbacks also favor these to the point where they're maybe $2 or $3 a replacement with the energy rebates. As far as their construction goes, they usually integrate a driver and LED array inside of either plastic or glass tube-shaped lens. I'm really not sure if the glass one's still around. I know that Philips was making glass ones for a while, but maybe they are not anymore. Easiest way to maintain existing T8 fixtures while upgrading the light source and lowering energy cost. So it's nice because it works within the existing maintenance paradigm. You have your driver, your ballast, and a lamp. An existing fixture. Guys generally get how to replace those. Just to keep in mind, as Ben was saying, I mean, they are not omnidirectional like a fluorescent. So you got a fixture that depends a lot on the reflector. It may work differently within that reflector. So mock-up's definitely needed. That said, a mock-up's usually fairly easy with a lot of these options. And when you can go for a wide beam angle, just to spread that light more. They come in 3 main types. UL type A, which is the T8 ballast compatible. UL type B, which is the direct wire, which more or less bypasses the ballast. And UL type C, separate, which would be a separate LED driver. Let's go into those in a little more detail on the next slide. So UL type A, these still, although they are ballast compatible, they still do have an internal driver that is powered from the high frequency output of the ballast. If you're not changing out the ballast, make sure the lamp is compatible with existing. Ballast compatibility is getting a lot better over time, but it's still worth checking the combination you're working towards is going to be compatible. It may be a good thing to change the ballast either way, just so that you're giving a good lifespan to the new install. And with the cost of these tubes, it can still be quite a good payback even when you're replacing valves as well. Just moving on to UL type B on the next slide. These are direct wire. Now you'll need to basically be rewiring the luminaire to have these connected properly in their sockets. One issue is, at least there was early on, may have been ironed out over time here, is that different direct wire tubes had different wiring configurations. So often you needed to replace sockets, and going on further with maintenance, you need to make sure you're replacing with those exact same tubes. Or you might have a situation where you're shorting something you shouldn't be. So a couple pros here. One, there's no ballast to maintain, which is nice. They still do have an internal driver, so their lifespan is pretty equivalent to the Type A's. Some cons there also that, especially with 347, you now have 347 coming to the pins of the lamp. Basically, it can mean a little more safety risk to those, relamping those fixtures. And also, just as with everything 347, there's lower availability, higher cost to them often. So may not be the best option. Depends. You really have to weigh your options. One nice thing, because they are directly connected now, don't have a ballast in the way, you can often add dimming to these. That is one pro. It'd be like a line level dim you could usually put in. But overall, I still feel like the Type A is a little better option in most cases. Moving on to Type C. Now, one great thing with this was having a separate driver, the actual LED driver. The tube's just an array. They're the highest efficacy. You get the benefits of an LED driver, so higher rated life, and basically you can replace the driver and the lamp separately, so that array will last longer in the fixture. And you have the safety of a lower voltage at the pins of the lamp. Cons is they generally are the higher cost, just due to, we've gotten ballast costs so low over the years that even newer LED drivers being around for a while here, they're still a little more pricey. So they're not a bad option. It just need to weigh the life cycle cost versus the upfront cost. I guess moving on to retrofit kits. So these kits will replace the lamp and ballast with an LED array driver. It can also include a new lens configuration, depending on the design. There are off-the-shelf ones, like a lay-in insert for certain sizes you might have, whether a 2x4, 2x2, 1x4. And there's lots of custom options. There's separate components you can source through a custom supplier that would be an LED strip, a driver. They may look at new lensing. Generally, let's go to the next slide. Let's talk quickly on the pros and cons of these. It's nice because you get a high level of customization, especially if you go the custom route. Or if you go with the off-the-shelf route, it gives you kind of a nice new look, which can sometimes be cheaper than a new luminaire. But it really got to look at these. A lot of them will come usually equivalent cost to replacing with a new luminaire. Maybe one of slightly lesser quality, but to an owner, sometimes they'll look at it and say, hey, for the labor cost involved, let's just go new. And then just there's the additional labor and coordination time you need to take into account for making sure that it fits in this fixture and the performance is what you want. So yeah, they're not all the way bad. It's definitely consideration. There's a reason that tubes aren't going to work. So, something in the fixture makes it not right. Or it's a very unique luminaire where it's just not going to work for replacement. It's something you can consider. But go to the next slide. Okay, so yeah, the last would be the medium base LED screw-in lamps. So when you're selecting these, let's look at the lamp lumen output. What are you replacing? What's the incandescent equivalent? Try to meet that lumen output wherever you can. What's the color temperature, the CRI? Try to hit the existing color temperature. Usually if it's a incandescent You want to be in the 22 to 2700 range. And yeah, higher CRI is always better. What's the lamp size? Nice thing now is there's just about an LED lamps that almost matches all existing incandescent bulb sizes, which is nice. And what's the optical size and shape? Most of the I guess, bulb shaped ones are pretty omnidirectional. They do a pretty good job of that now. And what's the dimming capability? Of course, we're seeing really good advancements in this now of the dim to warm. So you almost dim pretty close to incandescent. That said, you usually need to have good pairing with the right triac dimmer or line level dimmer to get that performance. And I guess, yeah, appropriate technology. Generally, when we were looking at the incandescent to fluorescent change, there were some real trade-offs there. You got better energy, but you lost some of the dimming capability. It didn't dim nicely if it did. Newer LED screw-ins have really fixed that with the dim to warm. So they're usually, generally, the appropriate technology is LED. But look, I mean, LED dimming is not the same still. It'll always be a little bit off. Really talk to the users if they like that nice, smooth dimming right to the point they want. They may want to stick with incandescent, knowing all the maintenance and energy concerns. And move on to Ben here.
Yeah, so lenses and louvers, I guess if you're doing what Adam just talked about and replacing lamps, you don't want to replace the lamps in the fixture that you can see in the picture and keep the lens like that, because you're not going to get the light output you want out of it. So often you can get some efficiency out of existing fixtures just by cleaning the lamps or lenses and making sure that they're not cracked or causing light loss from dirt and other debris that's blocking your lenses or your fixture. There's often a lot of older fixtures that you see in, like, especially industrial areas where this is a real problem, where a lot of the parabolics and louvers and all of that sort of thing have really not been maintained over time and are dirty, and you're getting a lot of light loss factors that you wouldn't really account for in an original install or calc. So that's just something to keep in mind on the maintenance side.
All right, just kind of in general, you always want to strive to provide the best solution for the programming space, the light quality, the budget, energy savings, and decrease waste. And some of these questions can help. You know, how much light is needed? Like Ben was saying, more light is not always better. Can the light quality be improved using the same luminaire? Maybe, maybe not. You know, if you're putting in a more direct source, maybe it's not improving light quality. What type of lamp is appropriate for the task facility? Yeah, depending. Look at different lamp lumen outputs, color temperatures that work for where you're at. How many lamps are required to meet the light levels? Yeah, you can look at fluorescent fixtures may have too many lamps, more lamps than they need for what light levels should be. Should luminaire optics be changed or kept the same? Lensing can be changed in some cases to give you a little better output. That said, we're not looking at changing reflectors anymore like we would with fluorescents. So it's a little less on that end with LEDs. How can luminaire be most easily retrofit? Just like I say, tubes are generally your easiest path forward. Where that's not the case, you can look at the retrofit kits or the kind of custom module drop-ins. What parts of luminaire are usable? What needs to be replaced? Yeah, keep in mind things that wear out, like sockets and lenses, as Ben was just talking there. What types of switching control should be upgrade implement? Knowing the, I guess, limitations, I failed to mention that type A lamps, you're going through a ballast still. So you're still up against the same challenges dimming that fluorescents had, probably with an extra challenge of running this LED now. So it's dimming's mostly off the table with the type A ballast compatible lamps. But that said, keep that in mind when you're looking at retrofit. Maybe they want more control. So oftentimes they might just want more switching zones, which takes some rewiring, but often can be better than a lot of the automatic control solutions if they just want to have a little more control in their space. I guess moving over to Ben.
Yeah, so when we're looking at upgrading troughers, really it's this is going to be your standard kind of T-bar 2x4 or 1x4 office thing, where you're looking at do you want to replace the lamps in the existing fixtures? Do you want to replace with new? So you're going to look at what's the better option for the client. Do they have, like, are these fixtures being maintained recently? Are the ballasts good? So then you could maybe just go with like a lamp swap like Adam was talking about. Are the fixtures spaced correctly, or could we just go straight with a completely new redesign and lay out the fixtures in a new pattern that makes more sense with the LED light output? You're going to look at your IES manual to figure out the kind of light levels you need, like something like 300 lux for an office or higher, depending on what's going on. You may want to even like mock it up to make sure that people aren't going to complain that the lights are glary or causing other issues that may not be visible when you're just like looking at a floor plan layout. And then if you're using existing fixtures, you may want to look at replacing the lenses if they're damaged, dirty, or miscolored because of the sun or time. So that's kind of the things that you're going to look at when you're looking at upgrading troffers, just kind of the basics.
Okay, and strip lights, I mean, you'll generally see these more industrial areas. In institutional settings, you're mostly looking at service spaces, storage rooms, places where they weren't as concerned about the look of the lighting, they just need more utility. That said, always define the task elimination. Sometimes you might have a storage converted to an office and they got these ugly lights. They may just, a redesign in that case may be better than a retrofit. Look at your ceiling colors or flush mounted lamps. You may look at, in those cases, trying to get some painting done to give more reflectance in the room so that it spreads the light more, makes it less cavey. Now, new reflectors with LEDs, we're using reflectors less. It doesn't mean they can't help, but generally the more direct source, you're not looking at reflectors as much. But still confirm how the beam spread will affect the light quality. Since they are a more direct source, they can often give off more of a wave effect, like a dark ceiling at certain mounting heights, which doesn't look as nice. You know, if you had an industrial luminaire that had some uplight before and you're putting in a tube that's only downlight, it'll make a difference in the room. That said, these are service spaces where that may not be a big thing. Definitely do a mock-up where you can, if you're really unsure. Probably find a service room, but maybe more of an issue in a parkade, where you really want to hit certain light targets. Switching out from straight fluorescent to straight LED tubes, you may run into some issues of uniformity or just not getting the vertical luminance you need, especially in low ceiling areas. I guess moving on next to recessed downlights. So with these, you'll generally run into 3 options. Screw-in replacement, usually for the ones that have existing screw-in lamps, it's a pretty easy 1-for-1. You'll need to check and make sure that the lamp you're replacing in is rated for an enclosed fixture if it is. And downlight insert kits, kind of what you see in the bottom corner there. Those function very similar in output and function to the screw-in lamps. They give more of a different look to the fixture. Looks more complete. So mock up those and see how the owner likes them. It's just an easy mock up and see if they look okay. There are custom retros where you can basically bring in to pull out the guts of the can, take out the existing ballast or lamp, put in a new LED module and driver that fits just right for that recessed housing. Those can look really good, but they do take a lot of coordination and usually a little higher cost to do. And then just replace them with new. And with that, you're looking at just make sure you got a retrofit housing. One issue there is that often what's in the ceiling can't come out of the ceiling without major ceiling work. You have a really large retrofit housing above the ceiling, often you're just stuck with it. Other issue we run into those cases is when you have a existing really high halogen source. A lot of those, they're usually smaller bulbs, really high wattage. They thrive in really hot environments. So a lot of times the reflectors or the cans are in are really quite enclosed and big, where even if they did have LED replacement, it would just cook inside there and it's no good. So those can be really challenging times where often just a full replacement and ceiling work is really your only path forward. So Yeah, it's a few things to keep in mind on downlights there. Lots of options. Let's turn it over to Ben.
Yeah, so with high bay, low bay, you're dealing with existing mercury vapor, metal halide, HPS, aluminum reflector type fixtures with, or even T12 fluorescence. So I guess the original go-to to this, or earlier on, was T5HO multi-lamp high output fixtures with bright reflectors. You'd see this in offices or warehouses or even like hockey rinks, that sort of thing that you were doing. Now I think the go-to with, especially with the directionality and the ability to get high light output, you would go with LED pretty much everywhere and just pick the right fixture that suits the high bay environment that you're working on. So upgrading the lighting control system. So when you're doing this, we really need to figure out our lighting control strategy. Especially like if you're doing a new building, obviously you need to follow the NECB and follow that. And you still probably want to follow that when you're doing your renovations as well. The standards are different for renovations, but a lot of the recommendations in the NECB make sense if you're going full new lighting control system. You also want to talk to the people working there and understand how they want to use the light. Do they need to dim? Do they do a lot of presentations in their meeting rooms, or they want the lights at the front of the room off and the rest of the lights on? Do they leave the lights on all the time, or are they fine with turning them off at a certain hour during the day? How do they operate their facility? Is it 24/7 facility, or is it a 9 to 5, 9 to 6 type building? So understanding how the space is being used is important when you're considering how you're doing your lighting control strategy. So with that being said, the first and easiest is often just a time clock. So like I said, if it's a 8 to 6 type of office, well then maybe after the cleaners are gone at 9 o'clock, the lights go off until 5 a.m. the next day. And that's kind of an easy way to save a lot of energy without doing anything else. So that's kind of the simplest time clock strategy. Then you can go into the occupancy strategies where you put occupancy sensors just on the ceiling spaces. So places like storage rooms, washrooms, that sort of thing. You just walk in, the lights go on and only go on when people are actually in the space. Then you can add vacancy sensors in places like offices where people have to manually turn their lights on and the lights will go off once it detects that no one's in the space. So this is like a third layer of control. And with these vacancy sensors, you can often also add dimming for another added layer of control to that. And then the last would be like luminance-based strategies for varying the light levels in the space depending on dimming requirements, or if you're going to dim because of daylight sensors in the space. So we kind of talked about time-based already, but you can use like just an intermatic time clock that'll turn lights off. Often I use those for exterior lighting in particular. And then if you have a lighting control system in the building, you can often do it with your lighting control panel that'll have a clock built into it. With occupancy, you've got your ceiling PIR, passive infrared detector that just detects a person's heat. This is kind of the most basic occupancy sensor and something that's great for those kind of storage rooms, just like simple, like on off, big movement, large detection. You're going to get that covered. Then you've got the ultrasonic, which doesn't need that direct line of sight. So it's better if you're worried that you're going to get you're not going to get the movement that you need in the space, like restrooms. If somebody's sitting in the stall, you don't want them getting the lights turned off on them when they're not done their business. And then the dual technology combines both of those so that you can use the large sensor to turn the lights on, and then the ultrasonic to keep the lights on while people are still in the space, but not necessarily moving around a lot. There's also some plug load controls which have occupancy built in. You got to be careful with those so they're not turning on people's computers off when they haven't saved their work. And then there's wireless controls are also available now. So then with illuminous-based strategies, I'd say the biggest one with LEDs is dimming. You're able to dim almost all LEDs now relatively easily, and that just gives people a level of control that they didn't normally have when you were dealing with fluorescence. Fluorescence, you often just had to do partial light level changes by turning off sections of fixtures or every other fixture so that you're dimming just by turning things off instead of getting a natural dimming effect by turning all the lights off at the same time. You can also do scene selection, so your conference sensors, meeting rooms, halls, that sort of thing can now have a scene preset for different types of occupancy. And then you can just still have, often you want your manual controls for overrides. Like if you're doing a time clock, there may be situations where the time clock doesn't make sense. So you'd like to install a manual switch to override that in case something is going on at 3 in the morning on a Thursday night in the office and you all need to be there.
I'll touch on daylight harvesting. Daylighting can save a significant amount of energy, improve comfort in the room, but it takes a fair amount of time and coordination to get right in a retrofit. The best daylighting generally will be in a new build where the architect and the team can be focused on making a building that harnesses daylight the best. In retrofit conditions, it's a little more of an uphill battle sometimes to get a daylighting system that works the way that users want it to. So in a retro, this include modeling properly, placing photosensors, exactly where they go in the room to have the right pickup, rewiring, and new controls. And after all this, you gotta make sure that the light you do let in isn't glare. Basically, you need blinds that aren't blackout shades, more just you can reduce the amount of illumination, not completely cut it off. It's a lot to manage, so you really need buy-in from the client and the users to pursue this on a retrofit. Let's move into the next slide. So yeah, for daylight harvesting, really want to make sure you include time for commissioning in the budget when you're proposing a new project to a client, because if they do want that, it's a big undertaking. It's not just one little control measure you add on. It's a big thing to do. The technical implementation of it really varies between manufacturers. I haven't come across one that I love yet. It's usually a lot of fine tuning, kind of trial and error to get right. So it may mean multiple trips back to set up the system to a point where the user is not going to just disable it. Now, and yeah, Ben's touched on occupancy sensor tech. Really choose appropriate tech. I know certain sites, they don't want to use ultrasonic at all, which can limit how well you can use these the PRI sensors. But where you can also keep in mind, ultrasonic is fairly sensitive to ambient conditions. If you place them near air vents or just louder equipment, it can make them really hard to get them calibrated correctly. When you're looking at switch mount PIR sensors for smaller rooms, in existing buildings, often there is no neutral running to the switch. You have to find sensors that run without a neutral, which they do have, but you just can't spec anything. And really, it's always a big communication game. Don't assume anything that the owner wants. Often more zones can, just having more switching zones, period, more manual switching zones can be much better than any automatic system. Usually, and this is more in privately controlled spaces, and in public areas, automatic control systems definitely work. You want to limit their usage in more personal offices. Sometimes classrooms, teachers like to have certain lighting exactly when they have it or want it, and an automatic system might just get in the way of that. So really know what you're putting in. Like with everything, there's no case where the same solution works everywhere. I'll turn over to Ben.
The other thing I would add is just making sure that you remember the voltage that you're working with. a lot of lighting we've done has been 347 for the past few years. Now LED has kind of made it preferable to do everything 120 volts. So if you're upgrading your lighting controls, make sure that everything's going to be compatible with the 347 that you're working with. And if you have some sort of combination of 347 and 120, make sure your panel can actually do that properly, and you're not going to worry about dual voltages in a panel and things like that. So that's just something to keep in mind on the voltage side. When we're talking about upgrading lighting or exit signs, it pretty much means that you should probably replace them. Notably, because if you're replacing exit signs, you probably should be going to Running Man anyways, so you might as well just get a new green exit sign instead of trying to replace both the face with the Running Man and the light in behind it with an LED. There's a lot of work there, so at that point it just kind of makes sense to just go with a new sign. If for I don't really know of a situation where you would have a Running Man but not an LED in it at this point, so the kind of counter example doesn't really happen. So in this case, I think you're just going to want to replace with LED. So we're going to go through now just a few application examples to kind of demonstrate what we were talking about before. So Adam and I will just go next to see what we're talking about.
All right. Yeah, we've cut down. They had a pretty exhaustive list originally in this presentation. We cut a few down just for time. So I have some time for questions here. But first we'll take a look at is the parking garage upgrade. So we replaced a 175 watt metal halide piston system with 112 watt LED. You can see a nice before and after photo there with the metal halide on the bottom and LEDs on top. The integrated occupancy sensing and daylighting controls. And they were able to reduce load substantially, adding in the control savings, like 70 to 77%, quite good. So a 1.3 year payback, it's really nice. One thing to just consider when doing parking garages, try to keep the existing layout limit, so it's basically to limit new wiring conduit you need for your new fixtures. They'll weigh this against, if you did that wiring, you could use more lower cost luminaires. Maybe overall, there'd be better payback. And I'll just note on integral occupancy sensors, they're a really cost-effective way to see control savings. But do run it by the client to make sure they understand how those lights will react to cars coming down the lane. They don't like lights turning on one by one as you drive up, and they want zones. You got to implement that early. And it is a bit of extra wiring and coordination to have it set up properly. But that said, it gives you a little better vision into the parkade. There's more safety in that, having zones come on way ahead of you. Anyways, that's about it. Turn over to Ben.
Yeah, so industrial lighting, in this case, they went from 400 watt HPS fixtures with obviously the yellow poor color rendering index to 54 watt T5HO fixtures, and they got quite a good payback and return on investment. And this probably would be increased now if you went straight to LEDs even further. So you can reduce a ton of load by going from something that's a less good fixture, providing you terrible color rendering and just feeling like a dark, dingy sort of place, to new, brighter, better CRI fixtures, and you're going to save money. So that's really, when we're talking to clients, it's kind of a win-win all around with both better lighting and quick ROI and payback.
All right, next is an auditorium upgrade. So what they had was existing 90 to 250 watt halogen par 38s and downlights. Kind of spotty distribution, you kind of see it was kind of more pockets of light and inconsistent lamping. So probably over time, maintenance guys put in different lamps that weren't to original spec. Yeah, because it sounds like they had to use scaffold to get reach these high ceilings, which be quite costly to change out lamps. And considering the lifespan of your average incandescent lamp, that was probably fairly often. So big cuts there. So moving to LED retrofit modules. So talking about having kind of a custom module put into the can, which allows full dimming compatibility, which you really do want in for house lighting and auditorium. You don't want just on off. You need to have a nice even dim. So if you can get that using LED modules, that's great. So as you can see, the lumens levels evened out. Probably makes it easier. You know, full lights on, people can see everything under their seats, all that. And 77% lighting energy reduction with 3.5-year payback, which is pretty nice.
So we're going to look at an exterior upgrade here. Historical lighting, I think this is one of those areas where LEDs really shine, mostly because of the directionality of fixtures and how you can get tight beam angles. You're not getting that omnidirectional blast of light that they had with HIDs. They're just kind of flooding the space. You can really like aim and get these lines of light across the facade really where you want it to be, so you can highlight the architecture, hopefully how the architect or whoever really intended. So like it's kind of a night and day difference between the two fixtures, and you're still saving energy and cutting your electricity in this case by 43%. So it's really nice when you can take an old design and then spruce it up like this with directionality and aiming and not really adding any major fixture changes or anything like that.
All right, and onto retail lighting upgrade. So at Staples here, where parking lot you had 400 watt metal halides. They went to 42 watt LEDs, and loading docks had 6 watt halogens. They had a screw-in par 38. Interior, I mean, this is probably some time ago, so they went from 32 watt T8 to 28 watt T8, so kind of energy saving T8 route, which looked pretty good payback at the time. And yeah, retrofitting the ballast to high efficiency at the start. Apparently with load shedding on them, which is great. So when applied to 700 stores, that's it adds up if you can kind of follow this plan. So $1 million a year is pretty good on the balance sheet. So I'll just note here that, I mean, this is fairly still pretty early for LED implementation. You can kind of see they might have been limited in the outdoor fixtures they chose. Even from the picture, it looks a bit glary on the building mount. But yeah, just, I mean, there's better fixtures now. You can take your time to get more controlled lighting on those kind of fixtures. But overall, I mean, I think that's a pretty effective project, even with using T8 technology.
All right, thanks everybody.
And any questions in the chat here? Oh, one thing I forgot to note, there is much like the T5 or sorry, the T8 compatible lamps, there are now T5 and T5HO compatible. The same UL types apply there. So that changed just recently. I think when I checked these a year and a half or so ago, they weren't quite there yet. So like with everything LED, it changes quickly.
So I guess, Adam, there's one question for you here. It's T8 LEDs. At what point is safety recertification required? Type A, B, or C?
B or C for sure. Type A, it's hard to say. It's something you want to run past your ASJ. I mean, you're changing the lamp type that's going in, but effectively the luminaire itself is not changing. It's still effectively a T8 luminaire. You're putting in a T8 compatible lamp into it. So I don't see it as something that needs recertification necessarily, but I'm not the ASJ. Definitely something you want to check with them that they want to, if they're going to be looking for that.
Yeah, I would guess not, just because I think those are the type of things you can buy at Home Depot now and swap out your house, right? So
yeah.
All right.
So yeah. Ben, what have you seen, like your experience? Have you done more on the lamp side recently, or the redesign new fixture?
I would say I've done a lot of the redesign. Like I find that a lot of the owners are they want new fixtures that they know that they are going to work for a while, and they'd rather just do it that way. I did just do a large lamp replacement at the Vegreville Technology Research Center. But in general, I'm seeing like the city of Edmonton doesn't really want lamp replacements. They want fixture swaps and redesign.
And they're not too concerned with end-of-life issues. As long as
They,
you have fixtures to replace
yeah,
them.
they do have specifics regarding that where they want to make sure drivers are they're easily replaceable, that sort of thing, lenses, drivers, so that they can maintain.
I've got a question in the chat here for you guys. Do you encounter issues with ceiling work when doing a lighting redesign versus luminaire swaps? At some point, should architects be engaged to coordinate this ceiling work? Most of my experiences are that the ceilings are ignored or the electricians have to repair it.
Yeah, it guess would come down to the extent you have to modify that ceiling. T-bar is easy. I mean, if you're taking, if you got 4 lamps in the office, you're going down to 3. It's a T-bar install. Any contractor can manage that. You're just putting in a blank effectively. Where it comes into play is like, say you have like a fair number of buildings have these tropper style air handling luminaires.
Yeah.
If you find those aren't going to work anymore, you can't retrofit them, or the client doesn't want them anymore, that's pretty major ceiling work, because you're involving also mechanical to get new diffusers in certain locations, and a redesign of the ceiling in most cases, because often those are actually an odd grid as well. So there'll be like a 5-foot fixture or something weird.
Yeah.
So yeah, there are special cases like that, but generally just the extent that new fixture swap out versus redesign, what that's going to entail. And yeah, when you're looking at the initial assessment, it's a good time to bring that up with the client of what this is going to mean architecturally. That's got to come into that and get that those disciplines engaged early on.
I do find some clients are right away doing both a ceiling replacement with new T-bar tiles and the whole thing, and lighting replacement at the same time. Like I think Canada Place as an example is one that they're doing both over time.
Yeah. I mean, drywall is generally a cheap trade. Of course, nothing's cheap nowadays, but yeah, in a lot of cases, it can be done more easily than you might first think. All right. I guess any other questions, or are we about there?
I'm just looking through the chat. No, I think that's about it, unless anybody in the audience has any comments, or they could throw it in the chat or unmute. It's up to you guys. Perfect. I think we're good. Well, big thank you to everybody for joining, and thank you to Ben and Adam for the presentation. I learned a lot, and I think everybody else here did too. So great. Thanks, everyone. Have a great.
All right. Thanks.
Thanks.
Thanks.